Seriously? All my Ninja Turtles? Okay. All right. Love you too. Bye. Oh, hello. Let's do some application problems for Chapter 5, these rational equations that we've been doing. Here we go. Our first type of problem, we've done something very similar, these work problems. So usually it was like, I can mulch a garden in 7 hours. My friend can also mulch a garden. Together, we can mulch the garden in 5 hours. How long would it take my friend to mulch the garden all by himself, right? Those type of problems. So usually it was like one person's work rate plus another person's work rate equals the total job. There's a bit of a curveball though on this first one. An empty oil tank can be filled by a pipeline in 10 hours. Hey, that's familiar. We could say like 1 over 10 if it'll show up. That might show up eventually. The tank can be emptied in 20 hours by opening a valve. If the valve is opened while the pipeline is filling the tank, how long will it take for the tank to fill? It takes me 10 hours to fill this bad boy. I don't know why someone would open the valve and have it drain out, but they're kind of sabotaging me here. So they're not actually helping me, they're hurting me. So instead of adding them and their rate to me, we're going to subtract. They're draining this thing in 20 hours. So here is me just working so hard, filling this oil tank. Here's them sabotaging me, draining it out in 20 hours. We want to know how long it's going to take to complete the job. So what we did earlier when we were solving problems like this is we multiplied the entire equation by a common denominator. The least common multiple that we can have, or the lowest common denominator, would be 20x. So 20x times 1 is 20x, divided by 10 is 2x. 20x times 1 is 20x, divided by 20 is x. 20x times 1 is 20x, divided by x is 20. Oh, 2x minus x, okay, that's x. X equals 20. Done. 20 hours. Which makes sense, because it's draining half of the oil I'm putting in there, right? If I can fill it in 10 hours, and it's draining in 20 hours, it drains half as quickly as I can fill it. So in 10 hours, it's going to drain out 5 of those gallons. I don't know. And then in 20 hours, it would have drained out 10, leaving me with the 10 full tank. 10-hour full tank. All right. The other type of problem is the distance, time, rate, time, and distance. So the formula that we start with is distance equals rate times time. And sometimes we might need to readjust that formula. But to me, it is most helpful to come up with a chart for our problem here. A car travels 300 miles in the same time that a freight train travels 200 miles. The speed of the car is 20 miles per hour faster than the speed of the train. Find the speed of the car and the speed of the train. So I'm going to come up with 3 columns here. A distance column, a rate column, and a time column. We're going to calculate it for the car and the train. So it said that the car traveled 300 miles. So that's its distance. The freight train traveled 200 miles. All right. The only other piece of information it seems to give us is that the speed of the car is 20 miles per hour faster than the speed of the train. We don't know how fast the train's going. Let's call it x. Now, if the car is going 20 miles an hour over that, we can call that x plus 20. Now, think of our original formula. Distance equals rate times time. If we're calculating the time here, and you wanted to readjust that formula, to get time by itself, you would divide by the rate. So time is equal to the distance divided by the rate. Now for the car, the distance was 300 miles, and the rate was x plus 20. For the train, the distance was 200 miles, and the rate was x. Great, our chart is complete. Let's see what kind of equation we can come up with. The other piece of information it says is it travels that in the same time. So their times are going to be equal to each other. Here's the time of the car, here's the time of the train. We could set those equal to each other. 300 over x plus 20 equals 200 over x. When you have one fraction equals one fraction, your best bet is to just cross multiply. So we'd have 200 times x plus 20 equals 300 times x, which is just 300x. So if we distribute 200x plus 4,000 equals 300x. Let's get the x's on the same side. Okay. Subtract the 200. So 4,000 equals 100x. And then we divide it by 100. And you're left with x equals 40. Now, it doesn't just say to find x, it says find the speed of the car and the train. Well, the train's speed is equal to x, so the train is going to be 40 miles per hour. The car is going 20 miles an hour faster than that, so 40 plus 20 would give us 60 miles per hour. So the car is going 60. And the train is going 40. Now, if you thought, how could you check that? Well, think the car's going 300 miles. And if the car's going 60 miles per hour, that means that would take the car 5 hours to do that, right? Because if you did 300 divided by 60, it comes out to 5 hours. And the train's going 40 miles per hour, and it's traveling 200 miles. So if you did 200 miles divided by the 40 miles per hour, that would also come out to 5 hours. So they're both traveling 5 hours there. Nice. This is the last type of problem, the mixture problems. A chemist needs to make 1,000 milliliters of a 30% alcohol solution by mixing 25% and 55% solutions. How much of each should she use? So here's what I like to do for my charts with these mixture. I put a column for the amount of solution. I have the percent of that solution, and then I have the percent times the amount, but I do it in decimal form. Those are my three columns. So we have mix 1, mix 2, and we'll have the blended mix. All right, let me make my chart look a little cuter, cleaner. Here we go. All right, it says that the chemist wants to have 1,000 milliliters altogether. So the blend is going to have 1,000 milliliters. They want it to be a 30% solution. Now, if we were to do the percentage times the amount, but in decimal form, 30% as a decimal is 0.3. We're going to multiply that by the 1,000. Cool, we'll come back to that. Mix 2 and mix 1, we don't know how much we're going to put in there. But let's say I want to use X amount of the first mixture. Let's say it was 400 milliliters, and I want 1,000 altogether. If I wanted to figure out, well, how much would that be of mix 2? You could do 1,000 minus the 400. I made up the 400, but we could do 1,000 minus whatever mix 1 is. So now let's assign the percentage. Mixture 1 was 25%. Mix 2 was 55%. Now we're going to put those in decimal forms times the amount. So our first one, 25% is 0.25 times x. Our second amount would be 0.55 times 1,000 minus x. Okay, so we have solution 1 plus solution 2 equals our blended solution. Now, how can we represent solution 1? Well, that is the 0.25 times x. So we'll say 0.25x plus solution 2 is this 0.55 times the 1,000 minus x equals the blend is this 0.3 times 1,000. All right, let's go ahead and do our steps. 0.25x plus 0.55 times 1,000 is 550. 0.55 times negative x is negative 0.55x. 0.3 times 1,000 is 300. Combining our like terms, a quarter minus 55 cents would be negative 30 cents. So negative 0.3 plus 550 equals 300. Get rid of 550 by subtracting it. Negative 0.3, oops, I forgot my x up there, equals negative 250. And then we'll divide that by negative 0.3. Now this one comes out to a decimal, which is fine. I forget what it is. 250 divided by 0.3, 833.3. So let's just call it 833. Now, let's make sure that milliliters. That might be the question they're asking. Oh, it says how much of each should she use? So x is going to equal 833 milliliters. So that's 833 of mix 1. Now for mix 2, you would just subtract 1,000 minus 833, which leaves you with 167 milliliters of mixture 2. Great. That's our answer. So mix 1, which is the 25%er, is 833 milliliters. Mix 2, which is the 55%er, that was 167 milliliters. Now again, we rounded to the nearest whole on that. A chemist would probably want it a little more exact. Here's something else we could check. If we look, if we're doing 833 milligrams at 25%, if we did 833 times 0.25, it comes out to 208.25. If we did 167 times 55%, or 0.55, 167 times 0.55, that's 91.85. If we add these up, it comes out to 300.1. Now look at our total mix, the blend. 1,000 times 30%, 0.3 times 1,000 is 300. So we ended up with 300.1, but again, that was just because of the rounding. So it all works out, it all works out. Let's practice some of these today and maybe tomorrow.